Today we'll look at the Gaussian fitting tools available in the Beamworks environment. I'll show you two separate tools, and both of these are also available in Beamworks Strata. In this video we'll look at the first tool, which is within the BeamViewer utility, and the next video we'll look at the more comprehensive option, the Excel Analysis Export. Both tools are accessible right here from the QA Planar View tab in Beamworks. I have a Beamworks Gaussian fitting demo loaded in, which is a 13 beam star shot from a varying gantry delivered at 150 MeV. And so the simplest way to look at Gaussian fitting is to go to View Beam Profiles to bring up the BeamViewer. So here you can see the Beam 1 entry profile. You can press the 1 key and the 2 key to view the entry and exit spots. If you hit the spacebar one time, you'll enter the Profile Measurement mode, which shows the beam spot from a top-down perspective. You can click and drag left and right to change the orientation of the beam spot being measured, and we'll be able to perform a Gaussian fit on a profile at any arbitrary orientation. But for now, let's press the End key, which realigns the spot to the 0-degree orientation, and spacebar once more to return to the Profile Measurement mode. Let's take just a minute to talk about the beam spot coordinate conventions. Generally speaking, the XRV is going to be aligned with the y-axis of the IEC gantry coordinate system, so the camera is going to be aligned with that y-axis, and it's going to be seeing warped beam spots all around the center depending on the gantry angle. But when those beam spots are dewarped, they also get indexed so that the radial direction is always vertical. The bottom of the beam spot is the side closest to the apex of the cone. You can see in the beam viewer that the measurement bar remains horizontal and the beam spot itself gets rotated at your command. So at 0 degrees you can measure sigma x, and at 90 degrees you can measure sigma y. The first thing to understand is the data source for the Gaussian fit. Pressing the P key exports the profile data to a temporary CSV file. Let's just look at that profile data quickly. You can see it's normalized to 100%. Okay, so in order to perform an automatic Gaussian fit, you can press the G key, which uses that exact same CSV data we just looked at, but automatically inserts it into a template, which does most of the work for us. This Excel template is macro-enabled and runs automatically upon opening, so it'll just take a moment to compute. The first thing you'll notice is the sigma value here, displayed in blue, about 4 millimeters for this profile. In the header area, you also have the data size, 499 entries, the pixel pitch, 0.1 millimeters per pixel, and since the CSV file has normalized this profile, you also have the max gray value listed here in H2 to give you an overall indication of the peak intensity, and the orientation is listed as well. So the sigma value is based on the Gaussian fit, which is performed in the pixel domain, as you can see by the parameters in L7 to L9. You've got amplitude of 100%. The average value of the distribution is near the center point of the data at 251 pixels, and the sigma in pixels is about 40. That gets multiplied by the pixel pitch from B2 to give you your sigma in millimeters. To make things more intuitive, we plotted the curves in the millimeter space. You can see down here on the x-axis we have each millimeter labeled, and there are two measurement bars, A and B. A is on the left by default. You can drive those around by increments of 1 millimeter or 50 microns, and that's useful for measuring any features of interest. You may wonder about this error weighting column, column H. If you look over at R7 and R8, you'll see that the default weighting for both the central region and the tail region is 1. Those are the regions inside or outside the measurement bars here. And so since they're both 1 by default, we don't need to worry about them right away. But next, let's take a look at why you might want to use those features.